Hello, good afternoon to everyone from the editorial board of the BuildUp portal. For those attending a BuildUp webinar for the first time, we are very glad to welcome you. For our returning audience, thank you for renovating your interest. This slide to recall briefly what the BuildUp portal is. BuildUp is a collaborative platform in the field of energy efficiency in buildings. It is continuously updated and it represents a key source of information on the topic of energy efficiency. You can register and become a member of the community, which allows you to upload news, events, present case studies, results from a project, and so on. We also invite you to simply navigate the portal. In the Learn section, you will find all the podcasts of past webinars, and so it is possible to listen and see previous presentations. At the end of this webinar, the link to the full presentation and PDF deck of slides will be made available in this section of the portal. Upcoming webinars you can also find in the calendar of the events section. It is a pleasure to host today's webinar entitled Heating Systems in the EPBD Standards. This is a series of webinars we are organizing with the EPB Center and the RIVA, the Federation of European Heating, Ventilation and Air Conditioning Associations. And we have added some new dates for coming webinars that we invite you to take note and save the dates. They are going to take place in October 6th and 20th, then in December and still in January. You can take notes of the topics and in the build-up calendar or also in the agenda of the EPB Center. Now for today's presentation, I am glad to welcome our two panelists today. Johan Siringhibel, independent EPB expert, who will cover the role and place of the heating and domestic hot water system in the overall building performance. And also Lorenzo Cal, independent EPB expert as well, who will explain the EPB standards on heating and domestic hot water systems, advanced features and tips and tricks in his presentation. I will invite you all to contribute and participate in this webinar. You can type and send your questions in the dedicated box on the right-hand side of the screen, and we will bring these questions up and hear the answer from our panel after the presentations. Thank you for being here, and the floor is yours, Johan.
Thank you. Thank you and welcome to everybody. I am very honored to present the role and place of the heating systems and domestic hot water systems in the overall building performance. Just a few words about my standardization background. I am convener of ISO TC205 Working Group 9, which is focusing on the energy efficiency of HVAC systems. So it is clearly in the scope of what we will present also today. And although the others working groups where I am convener at CEN level, as CEN TC 371 Working Group 1, related to the overall approach, or to the holistic approach of building energy efficiency, and CEN TC 228 Working Group 4, which is making the calculation methods related to heating and domestic hot water system. I was involved in the preparation and coordination of the energy performance of building standards under mandate 480. So this was a mandate given by the Commission to work out the European standards and to help the member states to transpose European directive. And I am happy to be EPB expert in the EPB Center since 2017. So in a few words, my summary is a summary of my presentation. There will be 4 points. So the first one is the place of the heating and domestic hot water system standards the overall framework and the systematics. I mean, this is important. See where the different pieces of the puzzles come together. Then some data about the heating systems, the evolution and the new challenges. The idea is to draw a general picture of the situation and to show you how the different standards on heating and domestic hot water can contribute to it. Just two examples to show you that the impacts and the understanding, the conventions related to the heating and domestic hot water system standards, just to show that really training is needed to apply these new standards correctly. I mean, this is, as for all new things, training is very much important. And last but not least, my conclusions. So the place of the heating and domestic hot water standards in the core of the EPB standards. You may know if you participated to the other webinars that are around 50 standards. It looks like a huge number, but there is a big advantage is the modularity of the approach. So it goes, you see here this pyramid, it goes from the product, from the boundary condition and the product characteristics, comes to the energy needs of the building and then the energy use. And here is where we have the heating and domestic hot water standard, system standards. So there are about 12 standards. And then on the top of this pyramid, you have the E and ISO 52000, which is aggregation and conversion into primary energy. What is very interesting in this picture is to see that the product evaluation is now in a system approach and not before only in a product approach. So the heating system is really evaluated within the boundary conditions of the buildings. Here again, on this picture, you see the general structure in a more detailed way of the heating and domestic hot water heating standards. So it is EN 5316 series. So you see here in the small picture, you see that where is the energy directions. It goes from the source to the demand. So you have the primary energy, then you have the delivered energy, then it goes to generation, storage, maybe distribution, emission, and then to satisfy the heat demand. And here you have another arrow. It shows the calculation direction. So the calculation direction is the opposite. It goes from the demand to the source. So we calculate first the heating needs, and then the emission, distribution, storage, generation, and it goes to the primary energy. And this calculation flow, on this calculation flow are placed the different heating and domestic hot water standards. So it goes from the energy needs, but this is not a heating standard. Then it goes to the emission, it goes to the distribution, generation, and storage. And then it comes to the delivered energy and then to the primary energy. So here already you see how the heating standards are placed in the different calculation steps. And here I wanted to show you the systematic numbering. Well, it looks like a little bit complicated. It's also a little bit small, but I think this systematic numbering is very, very much interesting because it is independent from the ISO and CEN standards number. So, for example, you will have in ISO numbering, for example, 52,000, and you will not have the same number in the CEN standards. So, to find a systematic on numbering, it was invented this approach. So you have in the column here, you have the systems. So for example, column M3 is related everything to heating. And for example, in column M8 here, everything is related to domestic hot water. And then you find again the structure already shown before. So for example, the system parts are the needs. For example, line 2 are the needs. Line 3 are the loads. And 1.5 are the emissions and controls. And here you see then the different standards related to it. So with the systematic numbering, so for example, when I here look on an emission standard, heating emission standard, so it will be M3 because it is heating, and then -5 because it is related to emission and control. So in ISO, you will have another number of the standard. In CEN, you will have the number 15316-2, but with this systematic numbering, if you know that it is M3, so it is always related to heating, and then with the dashboard, it is related either to emission, either to distribution, either to generation. So I think this is very nice to find your way through the different numbers of the standards, which are very often not. There is no link between the meaning and the numbering in the ISO numbers or CEN numbers, but with the systematic, it should be more clear. So this was to show you the role of the energy calculation of the heating and domestic hot water standards in energy calculation. But we have not only energy calculation, we have only standards related to inspection. So I put a number here, but it's just to show you that, and also I show you here the systematic numbering. It is to support and transpose the EPBD requirements on inspection. So this is help for this. And then we have also measured energy. This is a support to close the gap between measured and calculated energy to avoid like a dieselgate. What does it mean, dieselgate? It means that the real performance and some calculated performance should not be different. And this standard helps you to show the results of the measured energy, and then you are able to compare it to the calculated energy. And then something maybe new, but it's already a standard here, which is already here for several years. It is an economic calculation, and I think this will become more and more important because in the EPBD there is a requirement on economic feasibility, and this standard helps to support and to transpose the EPBD requirements on economic feasibility. So this was a little bit the role and the place of the heating and domestic hot water standards in the general frame. Now, some, as I said already, some key data related to the heating systems, just to show you the importance of the heating systems also in the overall frame. So you may know that buildings currently account for 40% for Europe's total energy consumption. 30% are related to its CO2 emissions, and mostly for heating and cooling purposes. 35% of the European buildings are over 50 years old, and nearly 75% are energy inefficient. So there is quite a huge work to do. But unfortunately, renovating existing buildings, which could reduce significantly energy consumption, but is not so much done. Only 1.2% of the buildings are renovated each year. And some even more important value is that only 15% incorporate significant energy efficiency improvements. Last but not least, to show you that the heating systems is a huge market, because it is estimated as to about 20 billion euro. So all these data just to show you that HVAC professionals play an important role in energy efficiency update, also in renovation, because very often heating and domestic hot water systems are upgraded first. After having shown the general picture again, some words about the evolutions and new challenges related to heating and domestic hot water systems. So in the past, what was important was the dimensioning, the sizing of the heating system. So it was important. So it was related to kilowatts. So what was important is to size, to have the needed power, so that you are sure that you get enough heating, and very often the systems are oversized in the past. The products were characterized as products, as I said already before, and not as part of the system. So they were characterized by the nominal power very often, and the related efficiency. Okay, but now the things moved, and now, of course, the dimensioning of heating systems is still important, but energy consumption must be evaluated. So we do not talk only about kilowatts, but we talk about energy, so kilowatt hours. And without this evaluation, you will not get the building permit. So things are changing, of course. But very often the evaluation is more related to compliance, so to fulfill these regulations, than to the real performance. So this is what I mentioned before, this Dieselgate, the discrepancy between what is announced and what is really consumed. And why I say this? Because when most evaluation methods or calculation methods are based on monthly calculation methods, they have standard climate conditions and things like this. So it is maybe not so close to the reality as it could be. The products are characterized also by part load and not only by nominal load. So this is related to the Eco Design Directive on ERP, and part of a system. Unfortunately, we have no level playing field because we have 34 different national and regional regulations. A look in the future, let's say that 2020, 2050, but there are already game changers, because nearly zero energy buildings, new buildings should be zero energy buildings after the end of this year. The problem, as I already mentioned just before, is that the definition of nearly zero energy building is not harmonized European-wide. So there is no common definition, for example. Then the buildings are not longer energy consumer, but also energy producer. More and more buildings have photovoltaic panels, and so they are also exporting energy. So this has also been taken into account when talking about heating and domestic hot water systems. for several reasons, because maybe photovoltaic panels will replace thermal solar panels or things like this. So now building gate, now I call it building gate, because before I called it diesel gate. The calculation consumption should be close to real consumption. And in the new standards, the evaluation of heating and domestic hot water systems is based on an hourly method, which is already closer to the real energy consumption. And of course, because of the European Green Deal, sorry, I forget it in my list before, European Green Deal, which means that Europe should be CO2 neutral in 2050. There will be a huge European funding, of course, related to this. This CO2 neutral will have a heavy impact on the change of systems, because there will be a change from fossil fuels to renewables. There will be more storage, probably less power, and there will be more complex interacting systems, which will be more sensible to the boundary conditions. So this interesting to know is that these evolutions and new challenges are already taken into account, not completely, but in a large part, in the new set of the EPB standards related to heating and domestic hot water. So this will help the HVAC professionals to challenge this evolution. So how to adapt to these new challenges? As a professional needs to be trained on the more complex heating systems as renewables and storage. And storage, I think, becomes, as I already said, more and more important. The more boundary conditions depending standards, the heat pumps. This has to be taken into account in the evaluation and calculations. And there are new indicators, which the HVAC expert has to be take into account and to calculate, as for example, the share of renewables. Unfortunately, this is also not harmonized all over Europe, but it is mandatory in some European countries, primary energy, and then these notions as on-site, nearby, and distant. So the professionals and the industrials need, I think, a common level playing field for a fair competition between the products. And the optimization of the building energy performance. And industrials, for them, I think common databases and tools would be very much important. And I have the feeling that huge work has already been done on the building needs, but in some calculation methods, the HVAC systems are still the weak point in the software. So this is why the European standards are also related to heating and domestic hot water systems, but also for other uses, are key to create a level playing field. So it means common methods. And an advantage for mutual recognition and qualifications among the European member states. I think that this is very much important because today HVAC professionals cannot work on the other side of the border, and we have still a lot of borders in Europe because they need to be qualified and certified related to national calculation methods. And here I think this is really a key issue for the European standardizations because they create already the common methodology. a first European-wide qualification and training scheme based on the EPBD mandate it started for HVAC professionals has been created. It started, and I'm very happy with this, with the heating and domestic hot water standard. And if you want to know a little bit more about it, you can look on this link. You can go on the website of this qualification training scheme. So now I come to the two examples, just to show you how the impact and of the energy choice of heating systems goes far beyond the final energy, because and for this I put it on the screen as a table coming from the overall standard 52000 one. So here you have the primary energy factors, and you have the carbon emission coefficients, CO2 here. Okay. So I wonder if every heating, if all heating and domestic hot water experts are aware about the primary energy factors, that they know that there are primary energy factors for non-renewable primary energy, that there are primary energy factors for renewable primary energy, and the indicator for the energy performance according to the EPBD is a non-renewable primary energy. And here just some examples. So you see that here it will be for gas, it will be a non-renewable primary energy. For gas will be 1.1. For wood, it will be 0.2 and 2.4 for electricity. So this has, of course, a huge impact on what you install and how you are able to reach the requirements which are expressed in primary energy in the different building codes. And then something which I think that HVAC and heating and domestic hot water experts will be more and more confronted to will be the CO2 emissions factors. So here you see the impact, 220 for gas, so this is this column, 40 for wood, 420 for electricity. And then the renewable primary energy, which you need to calculate the renewable energy ratio. And here you have also some values just to show you, and some, and as already said, that this renewable energy ratio is mandatory already in several countries. And the heating and domestic hot water experts, they must deal with it. The last slide before my conclusion is the definition, something also which I wonder if the HVAC, the heating and domestic hot water experts are familiar with it. It is a definition of the assessment boundary. Just to show you the impact on the primary energy factor, because this is very much important. So the assessment boundary is a boundary where the delivered and exported energy are measured, or calculated. So here I just show you, this is an outcome of a picture of one of the standards. It can be placed on several places, and for example, it can be placed here intuitively. One may go for the boundary related to the incident solar radiation, but then it has some disadvantages because if it is here, the solar radiation would be counted quite in a huge amount in the primary energy, and by convention it is placed here on the energy output. So the kilowatt hours, the energy coming out, the electricity or heat coming out from the panel solar, and the primary energy factor is also, sorry, it moved. Okay, the primary energy is also one. This was only to show you the complexity. I do not have the time to explain it in details, but this is why we have our training sessions dedicated to these topics. So I come directly to my conclusion, and this is my last slide. So the advanced features of the EPBD standards, and my colleague Laurent Socal, he will tell you more in details just after my presentation on heating and domestic hot water systems, like the dynamic approach, renewables and things like this, complete the holistic approach of the buildings, and will help the HVAC professionals to uptake the new challenges. It is clear that to reach the European energy and climate targets, qualified building force is needed, and I think that HVAC professionals needed to be trained on the new upcoming challenges, which I showed you already several times: nearly zero energy buildings, renewables, state of art, and things like this. And we think that European founding related to the Green Deal could be really a game changer. But in our opinion, it must be based on a common methodology. Otherwise, no common reliable European targets can be monitored, because with different evaluation methods, regional or national, I do not say that they are good or bad. I just say that they are different. So it may be that the same building will be green in one country and black in another. And I think this is not the target of the European founding. So if there is European founding, then needs to be monitoring, and the monitoring cannot be done with different scales. So this is why we think also that European standards have here a huge a role to play. So to finish my presentation, European standards on heating and domestic hot water systems are a support for HVAC professionals to face the new challenges, create a European-wide common level playing field for HVAC products, and are an advantage for mutual recognition and qualifications among European member states. Qualification training could be recognized European-wide because based on a common standardized methodology, which are the new standards related to, which are also the new standards related to heating and domestic hot water systems. Thank you.
Thank you, Johan, very much. Very interesting presentation. I find very interesting your points on how these building services should be considered as part of a system, and also the importance of addressing the performance gap and how the use of EPB standards can tackle these issues. Let's hear now from Laurent Socal. Laurent, the floor is yours.
Thank you, Camilo. Good afternoon, ladies and gentlemen, and thank you, Johan, for having prepared the floor for me by a general overview of general picture of the standardization process. So my background, I have a very various professional experience as installer, designer, and commissioning, and so on. A lot of things that I will leave this for you to read. I'm also convener of the Italian Mirror Group on heating systems, and task leader for several EN standards, and active member of several working groups. And details are not so relevant on this slide. What's happening? Energy performance is a required design objective nowadays for both new and renovated buildings and associated systems. So we could say no energy performance, no building permit. So this means that energy performance calculation is to be integrated into the design process. And possibly it would be nice to have the same calculation tools and the same description of the building, both for sizing and for energy performance calculation, so that you know immediately what you are doing. And it has been already said by Johan, there is often a gap between calculated and actual energy performance. And this is a pity, because it means that maybe there's something wrong in the calculation, and the credibility of the scheme is also impaired. And these new EN EPB standards have several features that are not obvious at the first glance, but can be quite useful. Also beyond the bare energy performance calculation. You will see that the good energy performance calculation may even provide useful information for sizing purpose. There are ongoing changes in heating systems, so standards have to evolve as well. There is a technology shift from combustion to heat pumping, and several other generation technologies are available as an alternative. And due to the high insulation, increased gains influence, and reduced needs, efficient part load operation and a good room temperature control, in general, a good control is required. And if you consider also other services, we have to coordinate. And for example, you have availability of electronically controlled pumps, and we are shifting to variable flow operation. And very often you need technical water storage to match the use and generation, but also to improve the generator performance. So there are a lot of topics that are arising and require new calculation techniques. Of course, this increase of possibility is also asking something more. For example, you have to define not only the comfort schedule, but also the operation schedule when it comes to hourly method, for example. A comfort schedule is just at what time a certain level of comfort is required. But this implies a different system operation schedule. Just to make it clear with a graph, if we have occupancy, for example, since 8 o'clock in the morning, you wish to have comfort at 8 o'clock. But if your system is starting too late, then at 8 o'clock, you're still not in comfort zone. So you can feel discomfort. And if you do not take into account these kind of things, so discomfort might imply a better energy performance, which would not be fair. So you see that, for example, going to the hourly method gives some possibilities, but you have also to take into account further details. Of course, the fear is that this will complicate a lot the input for the calculation. Actually, this is not really true. For example, think about the gas pedal of your car, and in the past it was just mechanical. Now, when you are pressing the gas pedal, this is going to be acquired by a CPU, which will do a lot of calculation and decide how much fuel to inject in your engine. But for you, this is transparent because you're still pressing a gas pedal. This is something similar that is happening here. We just know that we have to anticipate there might be a default value, and by just saying, okay, we have an optimization system, this value might be automatically calculated. So don't be worried about such a very complicated input. That's not really the case for this standard. Another very important thing happening is a technology shift to heat pumping. What's the rationale behind? Usually we acquire the energy we require and just convert it and put it in our building. That's what happens with a boiler. But of course, heat spontaneously goes outside your boiler, your building, when you are heating. And another solution is pumping back the heat into your building. The advantage is that with just a little energy to drive the heat pump, you will be able to transfer a lot of free heat. So this can be very advantageous because you use just less heat than less energy, let's say, and you must be aware that we have to compare on primary energy, but indeed you have a gain. You are transferring, so getting something useful, which is more than what we used. And this, of course, is nice, but you have to know that the heat pump performance is extremely sensitive to operating condition. It's just like here, for example, the performance of this hydraulic pump, which is doing exactly the same, transferring back water upsides when it goes down spontaneously. Okay, so performance, how much energy you need to transfer back the water will depend also on the height difference. And that's exactly the same that happens on heat pumps. So your maximum power depends on the core source temperature, efficiency, COP depend on both temperatures, and ranges and sensitivity are quite high because, for example, efficiency for a boiler is plus or minus 10% depending on operating conditions. In that case, the range is 1 to 4 into the operation range, and 1-2% efficiency gain or loss per degree change of the source or sink temperature, so it's quite more sensitive. And it depends also on part load operation. And here, typically, you might have a gain or loss, depending on the way you look at it, of 20%. So another difficulty, it's the heat pump sizing is critical because the specific initial cost in euro per kilowatt is much higher than for a boiler. Plus, you use also you may want to use a backup because as a safeguard or for special tasks like Legionella and so on. So you need this technology is nice, but you have to care about some more things. Just in a glance, to have an idea what I mean, here you have the performance map, the COP of a heat pump at full load, depending on outdoor temperature and for different possible flow temperature. And just for example, at 7 degrees, if you are feeding low temperature floor heating, or maybe you're going to fan coils or to some radiators, indeed, from 30 degrees to 45 degrees or 50 degrees flow temperature, your COP might be 3 or 4. There are indeed good values, or let's see 2.8 and 4, but you see the range of possible efficiency depending on operating condition. And that's the issue for sizing, for example. If you buy a heat pump, typically the output power is declared at 7 degrees, but you need to go down to -7, -8, or whatever your climate. In any case, what you have when you need the most power, you get the less. So you must be careful about design. No problem, just take it into account. Just to show you that this is quite sensitive. And here again, we have the performance map of a heat pump. It's for one flow temperature. You have the performance COP depending on outdoor temperature, and you see the full load and part load characteristic. And you see that just the same heat pump in the same operating condition, you have about 20% difference from maximum to part load. So another influence parameter we have to take into account. So given this, what is the answer by EN EPB standard? So the hourly heat pump performance calculation offers, for example, the possibility to use either data from EN 14511 or 14825, which are the standards providing the heat pump product data for the best representation of the performance map. Since it's a wide map, you have two possible sources of data. Again, don't be worried. You will not be asked in practice to input all the data. For practical purpose of the calculation, you just select a heat pump and all the data will come along. Then you have to check the operational limits, temperatures and power to determine backup requirements. And you might have product limitation. Of course, the heat pump has an allowable temperature range and maximum power. Or it might be a control option. You prefer using another generator when the COP of the pump is not such interesting because of operating condition at that time. So you have to handle priority between domestic hot water and heating and calculate the water temperature, because without this information, without this precise information about operating condition, you might go off the goal with the calculation. And if somebody is still using the monthly calculation, be aware that to calculate the priority between generators with monthly, this is quite hard to do. There is a turnaround, which is converting monthly data to monthly bins, and you can achieve the result, mostly because of priorities. And we have more and more several generator possibility in a system. So there is also this kind of support. And that's even not enough for heat pumps, because we highlighted just some topics, but new products are coming, 4-pipe units that are capable of simultaneous heating and cooling, typically in the non-residential sector. And you have all these direct expansion and condensation systems, and even thermodynamic heat exchanger using exhaust air. So further development will be required to make these standards future-proof. And let's have just a small look at calculation of operating temperatures. This is not very well known. This is in the general part of 15316-1. There are some submodules, let's call them submodules, in Annex C and D to deal with the operating temperature of the, let's say, utilization circuits and of the generator connections. So you can combine so as to calculate the actual operating condition of any configuration of your system. And this is necessary for condensing boilers and heat pumps. And just to have an example, just a very simple example, maybe you know this typical schematics of to control coils in the air handling units. You have a freeway valve and you are deviating the flow when you require less heat from the coil. What's the result? Typically, you run a constant flow rate, and here you're mixing hot water with the cold water from the coil, and you have here warm water on the return as well. It could be much wiser to use a two-way valve and just profit of the reduced flow rate, which means reduced auxiliary and reduced temperature on the return line. So the common solution, you have maximum auxiliary energy, maximum heat losses from the pipe, no condensation if you are connected to a condensing boiler. This is a better solution, minimum auxiliary energy, profiting of electronic pumps, minimum heat losses, and possible condensation. This can be easily identified with these calculation modules, and it makes the difference when calculating the performance of your system. And as well, for example, maybe you think that just a floor heating is ideal for a condensing boiler, but if you are careful, you will know that sometimes you have a mixing valve. So here you have a reduced flow rate, a high delta T. Several boilers have a minimum flow rate, and again we have mixing. But if your boiler has a control about the primary pump, you may reduce the flow rate, and again you restore the low temperature to the boiler, and you are really condensing. This is a control option that is taken into account with this kind of standards. And of course, it would be a quite interesting feature for a condensing boiler to have this instead of some gadget to have a plus after the A. Okay, so you see that it's not only a question of product, it's a question of also of how it is connected to the entire system to get the real performance. Where you have dynamics, for example, this is typically for the storage when dealing with heating system. You know that for heating system and domestic hot water, dynamics looks not that important. Of course, for the domestic hot water, it's obvious that it's important. So there is a dedicated part for this approach. You see the model, it's a 4 layers model. We are calculating the temperature of the 4 layers in a storage. Typically, you have a lower region where you have your solar exchanger. You have an accumulation for the solar. You have a space for the backup heater, and then here you have your reserve of domestic hot water ready to use. And you may also take some heat for a heating circuit. And the description of all this kind of thing is just the same you use for a normal boiler. Just know which is the proportion of the volumes. And what will be the storage calculation? It will take into account that during a calculation interval, you have first an initial condition, you are first taking out water, so you have cold water in the bottom and then propagating upsides. Probably you have some heating output, you are taking heat here because you have a heating system, and you may notice that you take into account that maybe you require 40 degrees, so you're not allowed to take as much energy as you want, but only what is available. You might have solar heating in this area. You might have then the backup heater, which is bringing back your storage to 60 degrees, and you are here in the final solution. All these things happen without that you notice. We are just using in the best possible way the available data. And you can couple this with a solar panel, because of course the efficiency of a solar panel, how much heat you capture, actually you capture the heat, but how much you lose from your collector depends on the temperature in the collector. So by coupling this with the temperature here in the lower part of your storage, you can do an accurate calculation of the performance of your heating of your solar collectors. And you remove also another assumption. In the monthly method, you assume that this is always working, but sometimes you overheat, and if you overheat, this circuit will lock out until the evening. And this is easily seen, and you can see here, for example, a cloudy day, the red is collected heat, and the green is what reaches really the storage. And here you can see that here you are collecting heat, but at some time you overheat, and so no more heat is going to your storage. All this kind of things of evaluation is easily done without any more input than the standard input you use for the monthly method. But you may identify some common mistakes, like a too small storage coupled to collected to solar collectors. And you can also figure out the temperatures inside the boiler. You have the temperature of the four layers in your storage, and you see here is the bottom part and the other ones. And by this figure, you see that the dynamics show you the temperature inside your storage. So it might be that if you have a stress profile, that is a sizing profile, not the average, you might evaluate if you are still able to keep a reasonable temperature or not. That's a fast way to tell you that this kind of calculation, if you just change the input data, the same calculation method can be used also for sizing purpose, which was one of the useful things possible, to have the same description of the system and the same calculation method and giving you results useful for sizing and energy performance. So is hourly always okay? I always not of course for all type of calculation. So sometimes you might have issues, for example, if the volume is too small or too high, let's say, a need of domestic hot water. If the draw-off volume is more than the volume of your store, of course, this won't work. But you can split the hour in smaller calculation intervals, and you can also fix this issue. And the case of using profiles with a very small time interval is a way to solve the problem of the design. Actually, EN 12831-3, which is another standard about heating systems of the same series by TC228, is doing this exactly for the sizing of the domestic hot water. Actually, the method is quite similar. It's just running on a smaller calculation interval, and they could converge easily. Another feature, which is more and more important, that's general for the whole package, but this happens also on heating systems, is that if you insulate your building, it's more and more important that you take into account recoverable losses inside your calculation of needs. So you need, if you have components that may lose heat, that you attribute the recoverable losses to the right thermal zone. I remember you that the thermal zone is a set of spaces that share the balance of heat, of losses and gains. So it's important that you go to the right one, because if it's very well insulated, even low losses can influence significantly the balance of your thermal loss. So it means that you have to identify where are the components of your system. This is indeed highlighted by, set by the general standard EN ISO 52000, but that's a feature that can have consequences and needs to be known when using the TC228 standard. So we identify recoverable losses, and you have to attribute the right thermal zone. Just think about the domestic hot water loops which are heating your building in summer, which is not very good result. Hourly method, of course, is very useful for calculating what happens when you have the exchange between your appliances and the grid. Of course, monthly can do something. For example, for the heat pump, it's clear that you have probably more PV in summer and less in winter. whilst your heat pump should run in winter. You can capture this, but we cannot capture with, or it's quite difficult to capture the mismatch along the day. I don't see you have a mismatch along the day, and this is not captured by the monthly method. You have also the fact that the sun is here during the day and not during the night. So for the heat pump, for example, in winter, you have a few hours sun and a long run expected from your machine. And that's another example. There has been a specific, indeed, there has been a specific webinar, and there is a reference somewhere in this slide, but you can find it on the site of EPB Center about the comparison between hourly and monthly method. There's not so much to see about other domestic hot water and heating subsystems. Maybe there is one of the advanced features is a generator sequence, since we have a lot of technologies now to generate heat, even though combustion boilers and heat pumps is a major share of the market, but there are several others. I already told you about this turnaround for the monthly, and here you have the link to webinar 4 for more details. What's another question that has been raised is the gap between calculated and measured. And of course, if we want to improve things, we have to measure. You can't improve something if you can't measure. And actually, we are dealing with all these things. We are performing all this calculation because our goal is reducing the actual fuel use or energy use or CO2 emission. And if you look at what happens, there is a tremendous effort about calculation, and there is very little effort about measuring and seeing if you reached the objective. So we are building sophisticated buildings, complex installation, we are calculating, but do we really check if we get what we promised or expected? And we not often compare. And for example, if you implement energy conservation measure, do you really check if you improved as expected? And is there any standard that might help to reduce or to contribute to having a look to the actual energy performance? And what are the reasons for the gaps? Of course, there are several. It's not only the fact that we do not really measure or check what we obtained. We might argue, is the calculation correct? Do we take correct into account influencing factors? And are the standard conditions representative? Don't forget that, of course, for regulatory purpose, you will use a standard condition to evaluate, or standard use to evaluate your building and system. And the question might be, are these standard conditions representative? So no surprise if there is some deviation if they're not representative. And are the building and system installed as designed, or did something happen during the construction process? And are they commissioned and operated as designed? You've seen the influence of the flow temperature on the heat pump. Did the installer correctly set up the heating curve, or are we running at a higher temperature than necessary? So have the measure data been acquired and processed correctly? So there are several reasons for the gaps. How can we address that? One standard is particularly helpful. So the 15371-3 about measured energy performance. It's the standard whose primary intent is to cover the process of measuring the actual delivered energy amount. So you have rules to collect the data, to convert and filter them. You have rules to normalize and standardize and to validate the result. But with some tips and tricks, you can do much more with this standard. Its primary intent was to support the measured energy performance assessment, but there is much more to say. Is that difficult? One of the methods is the energy signature. You see here a simple Excel where in yellow you have the data you have to input. Okay, the date when you read the meter, how long did the system work during the day, the gas meter reading, and here you have something, the only difficult data, which is just the external temperature during the measurement interval. And all the rest is just the energy consumed and the power by division of energy consumed by the duration of the interval. And the result, if you present the data, is this curve. Okay, that's quite interesting. the colder the outside temperature, the higher the power you need. Okay, maybe this is obvious, but it's still there. And you see that the dominant influencing factor is actually the outdoor temperature, in this case for heating. And the correlation is quite good. But that's not the question of just getting this nice picture. You might get it in the official way. So I mean, for example, this is what happens in winter. This is what happens in summer. So typically a constant use, and this is odd points in the middle, and this has to be discarded. And where these two lines will cross, it's an important information. So there's a correlation between these points, the intersection, and the indoor temperature, by the way. But okay, there is a standardized way how to produce an energy signature. What is this helpful for? Well, any result of an energy performance calculation can be displayed in the form of a design energy signature. So the power you need compared to the outdoor temperature. So it is quite easy to have a graphical representation between what you designed and what you obtained. And in this case, I think it's not that good. And the difference is quite high. And you can even guess we have some clues about what went wrong. So you could do this systematically. So what you need here is just some reading, maybe one per month, one per 4 weeks. I think about smart metering. We always speak about smart metering. This could be an interesting application. Having the data to provide your actual energy signature and take out the design energy signature of all the registered design, and you can compare, just to learn and to close the gap with time. And another application, if you have your energy signature, in that case, you have one important information. Here you can read the power needed by your building in design conditions. So that's very effective when you are sizing a boiler for a renovation. But you could do the same with the design energy signature and get here information for the sizing of your heat pump, which is a much more interesting way of sizing a heat pump using or leveraging the information in the energy performance calculation. And this as a result to avoid a lot of oversizing. And you might apply this to monitoring. Think about monitoring. Energy performance shall be kept in time. So if you have a reference energy signature and you are monitoring, as soon as you have some outliers, you might wish to investigate. Well, here I used less power. If I can repeat this, I'm happy. Oh, here I used more than required. What went wrong in this field? Maybe just a change in use, a change in operation, but let's see what happens and let's learn how to drive our system in the best possible way. And you might also check renovation. If this was your energy signature before your renovation and somebody told you, okay, we will save 30%, just take this line down 30%. And here you will add points of operation after renovation. Here it's okay, and here it's the other way around, KO. So it's nothing, it's not good. So you can see if your renovation was successful. So why measure energy performance with these standards? And don't stop to the standard, but use these tips and tricks. The energy signature is a simple tool to present the result of energy performance calculation. By the way, in 52016, this way of presenting it is also suggested. And if you go to the spreadsheet, it will do the same. So you present the result of the need calculation, the hourly, in the energy signature form. You can visually compare design and actual, size boiler on existing systems, size heat pumps on new systems, monitor operation, check result of an operation. By the way, this could be an IPMVP level C method, and get information about indoor average temperature. And hopefully, it should be extended to cooling and ventilation. What about installation? The last gap, another gap could be between what is designed and what is installed. In this case, EN 15336 deals with installation and commissioning of heating and domestic hot water systems, and it is currently under revision to cover new technologies. and to make it fit for the full commissioning process. Commissioning is an odd word. We could have a much wider meaning, but this is another topic. And it will directly address the gap between design and install and set to work. And this includes some features like keeping control over changes during the construction process, and performing and documenting a complete, and the most important word is performing, and possibly documenting complete testing and setting before handover. You have an example here. Please find the mistakes. This is just an installation checked some days ago, and you see a perfect electronic pump, and they are throttling with electronic pumps. And just because they didn't notice there is a setting, and the pump was running with a head of 24 meters when 6 was needed. And as a chain reaction, with such a high head, the pressure was opening valves, so they were overheating rooms. So you see that by a simple bad commissioning, and they typically forgot to input the parameters in the pump, the result was a disaster in energy performance. And here we are at the conclusion. So why to have such advanced standards? Very often they tell you, okay, but just for a small house we are heating, just heating, that's enough what we have monthly. Maybe. The EU building stock considers a majority of buildings with suboptimal insulation until now and dominant heating needs. And the dominant are heating needs, where maybe sophisticated calculation tools do not make that much difference. And you've seen that renovation rate is not so high, but indeed, all new buildings in the EU and all buildings that undergoes a deep renovation shall be high performance. And there are ambition plans for systematic deep renovation of existing buildings. So if you have to support this, you have to go along with advanced standards. So the EN EPB standard includes several advanced features that are required to deal with high performance buildings, and the additional tools that will be very helpful to reduce gaps between design energy performance and actual energy performance. Of course, modern calculation tools need also, you need both modern calculation tools and trained experts to achieve the respective results. Please remember, so also EPBD, it is mentioned that experts should do the design and energy performance certification work. And be aware that modern tools does not necessarily mean more complex input data. There is something more, but really a very little amount of additional data compared to the big advance and to the data you already require for the calculation. And I think that's all. And thank you for your attention. And I give back the floor to the organization. Thank you.
Thank you very much, Laurent. It was very clear. Nonetheless, there are some questions we could discuss with you. I will start with a general one addressed to Johan to explain how the CEN standards could be linked to the European Green Deal in a concrete way. We address this question, Johan, please.
Thank you. Yes, it should be done in a similar way as it's done at national level, but at European level. What does it mean? It means that when you look on the national method, on the national level, you have something which is straightforward, which is consistent, which goes from the building, from building codes, so from for example, legislation. It goes then to regulation. You have some decrees or something like this. And very often in the decrees, you mention the technical tools. So it goes from the highest political level to the application on the field. And when we are talking about Europe, this should be done in the same way. I mean, you have the legal level, you have the which are the directives, Then you have sometimes then regulation, and then it stops. This is a problem, because then these technical tools are given related to member states. And here we have a problem. We have a problem because the results are not comparable. This is only because when you mention square meter, so the square meters, when you divide the kilowatt hours by square meters, only the definition of this square meter is quite different in the European countries. So how it could be, it could be linked to the European Green Deal, but we think it should be, if there is European founding, then it should be, the founding should be related to European technical tools, which are the European standards. So exactly in the same way as at national level, but at European level. And of course, because the problem behind is comparability, I already said, but also quality. And if, for example, the national tools have comparable quality, so results which are quite comparable to, for example, the reference, which should be always a European level, which are the European standards, then they could be used. But then there should be something like a certification scheme or a test bench or something like this to show the differences between the different countries. So to resume, the European standards should be the European standard should be the European tools, technical tools, where the Green Deal is based on. And this is called taxonomy, and there is already a taxonomy defined at European level, but the problem is that it stays at a very high level, and it doesn't go so much in the details, which is needed to be coherent for implementation and to be, how to say, efficient for implementation. So I hope.
Yes, thanks for this insight. I think it's indeed very important to reach for harmonization at a wide level. I will ask again to Johan a double-fold question on the training schemes. One is, how do you think, again, in the European wide level, how do you think this training and certification based on CE and standards could be implemented in Europe? And a practical question is if this training is already available, and if you can recall where people can address to reach this information and these trainings.
Again, in Europe, when it comes to final application, you are always at the member states level. And it is exactly the same for the implementation of the certification scheme. So today, the people responsible for the certification schemes are at national level. So you have German, Italian, or Slovakian, I don't know, training and certification schemes. As I said in my presentation, the problem is that they are also not compatible. So the advantage is that the SEN standards, they create a common methodology, and then this should be to be implemented European-wide. This has to be recognized by the national training and certification scheme, like in sort like an equivalence, you see, so like mutual recognition. So it is up to the national member states or national ASHWAC associations to recognize the European standards for their national training and certification. So in this way, it could be implemented European-wide. I think this is the only one. And I think there is an advantage because then if there is mutual recognition, It means that the people which are trained in Croatia, for example, they can then work in Slovakia because it is recognized also by the Slovakian ASHRAC association, for example. I think this mutual recognition is already done in several cases. I think personally, I do not have the information, but I guess. And the second part of your question is, did the training and certification scheme already started? Not yet, but it will be starting soon, I think in several months, and the infrastructure is already put it in place. And in my presentation, you find the link to the census scheme, which is a front runner of this training and certification European-wide. So just look on my presentation, which I think is available soon, and then go to the link to the census project, census scheme, and then you will find the needed information there.
Indeed, CENCE project. Thank you.
Yes, exactly. CEN-CE project. Exactly.
Yes. You both spoke about the performance gap, a quite important issue. And there is a couple of questions I will maybe ask Laurent to answer these. First, could smart metering help in using measured energy performance? And a complementary question on the topic is if you consider that it is needed to distinguish between energy consumption factors, from like distinguishing from heating, from domestic hot water, and from all the other consumption factors in this task of addressing the performance gap.
So thank you for the question. Of course, smart metering could be of a great help. Of course, when we deal with measured energy performance, we are, I think, at the beginning. So it's not very popular. It's not such popular and such a regular application like calculated energy performance. And the first step is, of course, comparing the overall performance. So in that sense, having smart metering, having the availability of weekly data or monthly data, and you can have meteorological data for any meteor station around Europe, and it's really not a problem. This could be a big step to start. And then the second thing that is quite interesting is that when applying the measured energy performance, the most difficult thing to identify is the internal use of the building. And in that sense, smart metering and IoT or these kind of things could be very useful in identifying the actual use of the building. Sometimes you think that the climate is a problem. Well, the actual climate is usually well known, measured in a lot of points, so it's not that issue. The issue is really what you're doing inside, because when buildings are more and more insulated, the balance is more and more depending on internal influences rather than on what happens outside. So it could really help, and I would encourage this to have also a distinction between the contribution of the very of the different parts of the installation. Of course, if you have information about operation of your system, you may have information on what is the performance of each part, which is quite another good information.
Thank you, Laurent. And maybe again for you, a question on your presentation. Mm-hmm. Can you clarify the relationship between sizing and energy performance calculation activities and the related standards, please?
Okay, thank you for the question. Yes, of course, it's it arises a lot of debate about this. When you design, this is a general term, and first of all, you have to avoid confusing designing and sizing. Sizing is just one part of the design process. The design process means that you start from a need, you have a customer that has a need for a building, for a system to have this building comfortable and so on. And your first decision will be to imagine a set of construction and technical system that will fulfill its needs. For this task, you need to size each component, be it the thickness of insulation, the thickness of the walls, or the size of the radiators, or the power of the heat pump. You have to know which item to buy and install. That's sizing. And sizing usually is done using the worst case condition. You will size your radiator for the coldest day you can imagine that will happen. And in doing that, you will take a lot of safety factors. And the second thing that comes later is, now that you decided which are the pieces of equipment that you put together, how do they behave, not in the only one condition that you use for the sizing, but in the everyday's life, which is a different operating conditions and different. And this will give the result that is known as energy performance during an actual or a standard season, depending on what you are doing. So historically, the first need, if you take heating, just to make things simple, historically, the first need was heating our buildings somehow. And the first standard was about heat load. So the first instant was how big shall be the radiator, how big shall be the boiler? And this was the question, full stop. Now we are asking for more. We are asking that not only you install this, you pretend that you have comfort, but we pretend that you have comfort using little energy. So you have to perform a calculation in everyday's condition. So we had new standards. In the past, we had the standard about heat load. It's 12831 in the case of TC228. And you had a standard about heating needs. It was the old 832 for the older that remember, and then it has been 13790, and now it's 52016. And it would be nice, since now you have to size, decide which component to use, and then you have to check if they pass the regulation check, that is the energy performance. It would be nice to have the same tools to do this task, because historically in the past, this has been two different tasks done with two different sets of standards, 12831 or the other one, and possibly also by two different people. What would be the ideal? Or just another example, think about the ventilation and cooling sector, where you use a completely different standard for sizing and then for energy performance calculation. What would be useful, what would be nice, is that now you describe only once your building, and at once you have to check, is it correctly sized? Is it correctly behaving as energy performance with the same description? And potentially this could be done by the same calculation method, just by changing the input data. I mean, you can use an input data. You could use, for example, for the sizing of heating, you could use let's call it a stress profile. I mean, a representation of the worst week you can imagine in the year, and then check if you have enough power to go through. And with the same calculation, you could then calculate your energy performance for the whole year. But you did the work of describing your building and systems only once. This is already what happened in 52016, for example, where you're using the same method with different input data to provide sizing information and energy performance information.
Thank you. I believe these are important clarifications. I will come back to Johan with a couple of questions. One very concrete one. You showed in your presentation table B16, I think, about the weighting factors like for energy, different energy sources. And the question is these weighting factors are determined by country? And the second question is general one on, you mentioned level field for HVAC production is important for the industries, for the industrials. How industry can support the dissemination and implementation of the new CEN standards?
Okay, thank you for the questions. So for the weighting factors today, they are determined for each member state, but sometimes the way how to evaluate them is not so clear, and in the SEN standards and ISO standards in 52000, you have default values for these weighting factors. So, for example, when I look on electricity, the weighting factor was, if I remember well, around 400, something like this. This is European, because in Europe there is still a lot of coal to produce electricity, but it is much lower in France, for example, where they have nuclear power plants. So in the SEN ISO standards, the default values are more for on a European basis. I think what is important is that there is a transparency, and this is why at SEN there is now a new standard, 17423, which provides some transparency to make these choices made at national level more transparent. So this was the answer to the first. To resume, yes, okay, it is based on national level, and there are European values in the default values in the EN ISO 52001. The second question related to level playing field for industrials and how they could support. Today, in the different countries, some technologies are treated in a very simplified way. For example, on-site combined heat and power. I wonder if, for example, for on-site electricity production related to windmills, if there are some standards or methods at national level, we have on an European level. So this already shows, these two examples show that it is important for industrials to have their products evaluated properly, just to underline this again, and how they can support it. A lot of professionals, for example, they have already technical academies where they train the installers and the people, the designers, and if in this training they use the European standards, this could be already a first step towards market uptake and use of the standards, and also to train the European HVAC professionals in a coordinated way. So they should use, if they use already fair standards for the European standards for the training, and they could use all the European standards for their sale forces. This would be already a first step.
Thank you. Thank you very much to you both. And for these final tips and recommendations for moving forward. I also want to thank all the audience, and I remind you that we have some appointments, some new webinars to come. I invite you to check again the agenda, and I hope to see you in this in new rendezvous. Thank you all, and with this we are closing our webinar today. Thank you all.
Thank you. Bye-bye to all.
Thank you. Goodbye. From my